Okay, so modeling motion using parametric equations. Okay, to give an initial horizontal and vertical velocity, you follow these two equations. Now, obviously, these absolute value signs are not used as absolute value signs here. In vectors, they're used as magnitude signs. So, the magnitude of the initial magnitude of the horizontal velocity is going to be measured as the magnitude of vector v times cosine of theta, whatever angle theta you're working with. And then same thing with y, except it's going to be the magnitude of vector v for vertical velocity times the sine of theta. Okay? All right. Sorry about that. I had to go get some toys for my son. He left them out in the snow. So I had to take a breather. Okay, so these are the initial velocities that you need. Horizontal positions after t seconds and vertical position after t seconds are given by these equations. Now, obviously, x is just going to be t times the horizontal velocity. Okay, so that one's pretty simple. You're just timesing by t. Vertical is a little bit more complicated because you're acting with a force on it. Now, technically, we should be putting an air resistance force here for horizontal. But since we're beginning with elementary stuff of parametric equations, we'll just leave it to act that it's happening in a vacuum. Okay. Now, vertical position after t seconds, it's going to be the same thing as what horizontal is, except it's going to be the vertical velocity, initial velocity. All right, but minus 1/2 times g times t squared. Now, g, if you're using feet, I think it's negative 16.8 feet per second squared. And if you're using, no, it's negative 16, not 16.8. And if you're using meters, it's going to be negative 9.8 meters per second squared. Okay, so you're going to have to use that right there. And this actually is a great reason as to why we use parametric equations, because everything is a model of time. So time is the independent variable, and x and y are going to be the dependent variables. Okay. All right, so this stuff should be pretty easy setup right here of working with it. Just please understand when you're working with vectors v that you find the magnitude first and then you times that by the angles and everything. So let's take a look at it in an example problem. All right, so we already know the magnitude of vector v. It's going to be 120 newtons. Okay, so if we wanted to actually find out what the initial horizontal velocity would be, it would be 120 times cosine of 40 degrees. Okay. All right, and then the initial velocity of the vertical component, or the vertical initial velocity, is going to be 120 times sine of 40 degrees. Now, if this looks familiar, it's because you're working with right angle trig again. I mean, it's just as simple as possible of what it's actually going to be. Okay, so to get the actual numbers, we use our calculator. Okay, so 120 sine of 40. Okay, so first off, the initial velocity is going to be 77.13 newtons. Okay, and then this one is up here is going to be, oh, excuse me, cosine. So that's going to be 91.93 newtons. Okay, that's going to be the initial horizontal velocity, the initial vertical velocity right there. Okay, now, in order to do the horizontal position after t seconds and vertical position after t seconds, you need a time. So we will answer that. What if t was 4 seconds? Okay, simple as that. So we plug it in. So x would be 4 seconds, or 4 times, and this is going to be the initial part right here, so this is going to be 91.93. Okay, so this is going to be 4 times 91.93. Okay, so that's going to be 367.72. Okay. And then y is going to be, it is going to be 4 times 77.13 minus 1/2 times, let's go feet. Let's just go feet with it. So that's going to be -16 times 16. Okay. All right, so let's go back on our calculator. So it's 77.13 minus parentheses 0.5 times -16 times 16. Okay, and so this y positioning is going to be 436.52 feet. Okay, and so this one's also going to be feet. So this is going to be, it's going to be a horizontal distance of 367.72 feet away from the initial point, and it's going to be 436.52 feet above the height of the initial point. Okay, all right, and that's it for modeling motion using parametric equations. Just remember some simple rules, and above all else, please remember gravity. Gravity, gravity, gravity. Hugely important. Thank you very much and have a great day. Bye.